All right, I am here because I wanted to have a little discussion about why there are two different formulas when it comes to using limits to find the derivative of a function at a point. So as you see on screen, there are two of them here. Both of them are used interchangeably depending on the book that you're looking at, the professor you're using, so on and so forth. But what I wanted to do was to demonstrate that you can use either one and not have to worry about it. Not only that, at the end of this, I wanted to show that you can convert from one to the other, and that way to show that they are in fact the same thing. Now, the first thing I wanted to do was to show that they are the same by grabbing any polynomial, throwing it in, and getting the same answer regardless of the formula that I use. So, all right, and I need some help. Yeah, Leon, pick some numbers. Pick some numbers. Sound good. One more. Doesn't matter because it's constant. Meh, 26. All right, there is our function. We are going to take this function and plug it into both limit equations. Now, for those of you familiar with the chain rule, for those of you familiar with how to do calculus in your head and the tricks that were shown, we already know what the answer is, and that answer is 20x plus 7. So let's just keep that in the back of our minds. That is the answer. We already know what it is. So if I get anything other than that, I did it wrong. But of course, that ain't going to happen. So I'm going to use the formula on the left first. And just do some quick copy pasting. Let's do for x for now. And this is going to be, first off, we just do some simple substitution. So 10 parentheses x plus h squared plus 7 parentheses x plus h minus 26, and then minus the regular equation again, which is 10 x squared minus 7x plus 26. And of course, the reason being for the minus, the sign flipping, is because we have the minus sign right here, which takes the original function and changes all its signs. And of course, this is still over h. Now, next thing. What is that? Next up, we're going to use some multiplying binomials and say 10. Special properties for them, so we just do this in our head. Oops. So 10 parentheses x squared plus 2xh plus h squared plus, and then some substitution. And then everything else just stays. Oh wait, well, to make life easy, the minus 26 and the plus 26, they cancel out, so we can just jump right into 10x squared minus 7x as such. Still all over h. Next step, more substitution, and we get 10x squared plus 20xh plus 10h squared plus 7x plus 7h minus 10x squared minus x. There we go. Still all over h. Alright. Now I have a 10x squared here, minus 10x here. I have a plus 7x here, a minus 7x here. And I can just cross all those out and be left with 20xh plus 10h squared plus 7h. I believe all the other terms are crossed out. Gone there, yep, gone, down there, gone, down there, gone, and gone. Okay. Yep, so we're just left with as such. Next thing after that, I have an h in every term now, and in the denominator, so now I can just divide everything by h, and that leaves me with 20x plus 10h plus 7. Now the last step is I'm going to set all the h's equal to 0, so this becomes 10 times 0, which is 0, so we're left with 20x plus 7. We're there. So that is a demonstration that it works for the formula on the left. Now, let's do the exact same thing, but for the formula on the right. So let me just grab this because we're doing this a whole lot. So now, once again, step 1 is just substitution, plugging in our function in where it needs to go, which I'm going to do as 10x squared plus 7x, and then minus 26. And then once again, the signs are going to flip, so we're going to have 10 minus 10a squared minus 7a plus 26, and this is all going to be over x minus a. And now, once again, I'm going to eliminate the 26's again, because that's minus 26 plus 26. And then what I'm going to do is rewrite the terms so that the x squareds and a squareds are together, and then the 7 and the a are together, or the 7x and the 7a are together. So what am I left with? I'm left with 10x. 10x squared minus 10a squared plus 7x minus 7a all over x minus a. Now for the first two terms, I'm going to factor out the 10, and for the second two terms, I'm going to factor out the 7. And you're left with 10 parentheses x squared minus a squared plus 7 parentheses x minus a, and once again, this is all over x minus a. So now I'm going to use the rules of factoring to factor x squared minus a squared. Everything else is going to stay the same. And because, again, it's a special property, or a special binomial, whatever you call it, let's easily write it as x plus a, x minus a, like such, x minus a, all over x minus a. So once again, I have an x minus a here, an x minus a here, and an x minus a here. So I can divide everything by x minus a. And when I do that, I'm just left with 10 parentheses x plus a, so what's left over there, plus 7. And now going back with some distributing, distribute the 10 back in, we're left with 10x plus 10a plus 7. Now, lastly, I'm going to set all the I'll set all the a's to be x's just so the answer comes out the same, but really it's either way. And you end up with 20x plus 7. Or 20a plus 7, really. It's the same thing. And there we go. I forgot to delete that one. Oh well. So as you saw, we got the same answer either way, so it didn't matter. The same polynomial resulted in the same, whether we did the one on the left or the one on the right, does not matter. And then lastly, can I convert the formula on the right into the formula on the left? And the answer is yes. And the way to do that is if you substitute x equals a plus h into the formula on the right. And what does that look like when you do so? You're still going to have the x minus a. You're still going to have the limits. That's going to stay the same. But now, this x right here is going to stay, is going to turn into a plus h. And then, of course, the minus f of a is going to stay. And then you're going to have on the bottom, this x right here is going to turn into a plus h minus a. And then, of course, right here, this x is actually going to change again to a plus h. So there we go. Everywhere there was an x, I replaced it with an a plus h. Now that I've done so, notice the numerator is exactly how we want it. Matches perfectly. And then in the denominator, copy that right there, you have a minus a, so that's 0, and you're just left with h. So there you go. There's just the h, there's our denominator. Now if we look at the limit, the only way a plus h is going to equal a is if h is 0. So this is the same thing as writing h equals 0. And there we go. We just took the equation on the right and turned it into the equation on the left. So the equations are the same. It doesn't matter which one you want to use. So don't feel like there's going to be a right or wrong answer depending on which one you pick. And with that being said, this is Manosrules. If you ever need any help with any math, middle school through college, anything you're stuck on, anything you want to go over, and you stumble across this channel, feel free to reach out, see what I can do. Have a good one, guys. All right, let's see if I can do this. Goodbye.